Hi, it's Professor Monty. Let's look at some examples of nonlinear functions. Let's start off with a linear function. So suppose I have f of x equals 3x plus 2. That's a linear function. Think in your mind, think y equals mx plus b, the equation of a line. And this fits that. You may have things in other orders, you may have fractions, whatever, but if you can put it in the form y equals mx plus b, it's a linear function. Okay, let's look at some things that are not linear functions. A quadratic function, an example of that would be g of x equals x squared plus 9x minus 7. Notice if that x squared wasn't there, it's a linear function, but the x squared makes it quadratic. So x squared is going to be my highest power, and it's got an x squared in there, it's quadratic. A rational function, here's an example, h of x is 6x over x minus 4. The way you notice a rational function is the variables in the denominator. If you just have a number in the denominator, that's okay, that's just a fraction. But a variable in the denominator makes it what we call a rational function. And then an absolute value function is easy to identify. You just have an absolute value sign in there someplace. All right, now let's look at the domain of each of these. Okay, let me just spin around in a circle for aesthetic reasons, I guess. The domain of a linear function, unless the graph goes straight up and down, we'll put it this way, or it's horizontal, the domain is going to be all real numbers. So I can plug in any value for x, I'm going to get a real number out for f of x. So we'll just say all real numbers. That's my big block R for all real numbers. A quadratic, the same thing. I can plug any value in for x, I'm going to get an answer. It's going to be a real number. Therefore, I plug in a real number for x, I get a real number out for y, or for g of x in this case. Domain's all real numbers. Now, here's the first place we run into trouble, the rational function. Remember, the denominator can't be 0. So remember, denominator can't be 0. Well, in this case, it doesn't matter what the top is. 6x is irrelevant, but x minus 4 can't be 0. Well, if I add 4 to both sides, we say, oh, x can't be 4. And so we can write, oh, it's all real numbers except x can't be 4. Now, some books will write that as it's all real numbers except 4. Means the same thing. We're going to write it that way. And then an absolute value, again, I could put any number in. I'm just going to calculate it, take the absolute value, I'm going to get an answer out. But all real numbers again. So a linear function can go in the form y equals mx plus b. Remember, f of x is y. A quadratic function you're going to note from the x squared. A rational function has an x on the bottom, and then, of course, an absolute value function has an absolute value sign. Okay, so we'll see all these different kinds. We'll learn how to graph these as we go on a little bit later, but that helps you identify at least these 4 types of functions.